Good evening, children.
Good evening.
Today, we'll try something different. Yes, the same main lesson continues, maths or physics, but in that function and its average and instantaneous rates, or a function and its average and instantaneous rates, average rate and instantaneous rate. Okay, that is function means something like of this form, y equals f of x, and its average rate, that will be written as delta y by delta x. The instantaneous rate, that will be written as dy by dx. We are just beginning to talk about the differentiation, or we are in fact dealing with a topic called calculus in mathematics. In a very at a very elementary level. In fact, in your mathematics sometime later, after doing functions in algebra in a big way, you will go to calculus there. But we cannot manage our physics lessons without a simple meaning and use of derivatives and integrals. So the first lesson on that is this: a function and its average rate and instantaneous rate. And mathematically speaking, this will be shown as delta y by delta x. Delta is what? The Greek letter. This is the capital delta, alpha, beta, gamma, delta. Okay. Delta y by delta x. Delta y denotes change. This is a finite change. This is infinitesimally small change. So today we try to understand the meaning and purpose of this average rate of change of a function and the instantaneous rate. Ramakrishna, you should join on time, otherwise you will miss. We already started the lesson. The new lesson today is a function and its average and instantaneous rates. I have got a limited but very focused and very meaningful approach to the whole mathematics we are doing here, and more so in this particular area. We can manage for some time without this, but that is not a good idea. You can manage without differentiation, without integration for some time. But you will not be doing justice to yourself and to the subject there. Though in the beginning it looks a little what you call new and abstract, isn't it? Mathematics is an abstract science. So it looks a little abstract, but since we'll be connecting it to physics, it may not look so difficult, children. All right. I'll be continuing. Vishnuvardhan, you should be joining on time. Right. Functions, relations, and the average rate and instantaneous rate. Functions, first thing. Relations, the second thing. And the average rate, third. Instantaneous rate, fourth. So 1, 2, 3, 4 words are thrown at us in the very beginning. Let us try to understand them slowly. Can you identify this figure, children? Mokshagnya, what is that figure about? Hello.
Yes, sir.
What does it look like?
Measuring the water.
Measuring water. Anybody else? Yeah, of course, water is there. It is all right. This is what you call
Amount of pressure.
Where is it? Precipitation what, sir?
see, don't you keep looking at the average waterfall? Today, some 20 centimeters of rain was recorded, something like 2 centimeters, 3 centimeters, like that. You keep hearing the a rainfall's measurement. This is what we call the rain gauge. Of course, this is specifically made into conical shape for different reasons, but you can as well measure it with a uniform cross-section cylinder also. You put it in water while the rain is falling, underwater, under rain you put, and the raindrops will be filling this. So by measuring the height for a particular time, people give the rainfall readings. So for example, from morning to evening, it was raining. People use some rain gauge like this. So after one day, they talk about average rainfall for that particular time. Or like that, you keep recording this rainfall for a season. This year, you'll say for this year, the average rainfall was some 10 centimeters, for example, very high, or 3 centimeters, for example. Like how the practical calculations of the rain gauge you don't require. Try to understand. What I was trying to tell you was, today 2 centimeters rain, tomorrow some 10 centimeters rain, one day there's no rain at all, the other day once again 1 centimeter rain, like that. So for a month, you can give the average rate of rainfall. This is called rain gauge. Very, very important for many things. But I'll show you something more familiar to you. What is this, children?
Speedometer.
Speedometer, right? What does it record? If the pointer moved and was here, for example, what will you say? The speed at that point is 80 kilometers per hour, you say. And if you press the accelerator, that might go to 100. You'll say at that instant, at that second, it is 100 kilometers per hour. So this is what you mean by instantaneous speed here. So speedometer records instantaneous speed. This rain gauge records average rainfall. So these are very practical things in engineering applications, children. Any question you have about these things?
No, sir.
I'll come back if you want. Now, we'll make a statement here. If y is f of x, or in full words, if y is a function of x, that is, if y is a function of x, it's already there, I need not have to tell again, then a small but finite change. Underline this word, small but finite change, delta x in x would bring a change delta y in y. To put it in very simpler terms, when you say y is a function of x, what you're trying to tell is that this y value depends upon the x value. As an example, if you take y equals x square, this is a function. What is a function? I'll come back, because I use the word function, I'll be discussing it. But here what I would like to tell you is this, because in our quadratic equations, we took this y equals x square, isn't it? Now we are calling it a function. Okay, so if x is 1, y is 1. If x is 2, y is 4. If x is 3, y is 8. So as x is changing, y is also changing, right? X equals 1 to x equals 2, you changed. Y changed from 1 to 4, right? So delta y is 3. Delta x is 1. Delta x means what? Final x minus initial x. Delta y is what? Final y minus initial y. So delta x is x2 minus x1. Delta y is difference in y. Delta stands for difference, nothing. Y2 minus y1. So since whatever this thing called y is depending on x, when you say y is a function of x, we mean to say that this quantity called y is going to depend on a quantity called x, and as x is changed, y also changes, and those changes we give names like this. A change delta x you cause in x, that should result in a change delta y in y, because y is depending on x. Okay.
Yes.
So shall I continue? But I simply use the word like function here. I don't know how much you know about function. Do you know anything about function? Anyway, in algebra, I have to do it in details. In calculus, you have to talk about functions in a big way. But here, let me give myself some kind of easy explanation of a function. Look at this. When you write y is f of x, y is called a dependent variable. You know what is a variable? It can take many values in a very simple way. F of x, function x is called independent variable. This is dependent variable. In this equation, x represents the input of the process, and y the output of the process, and f the function of the variable. In this equation, x represents the input of the process. Whatever we do, like when you write y equals x square, you are squaring, isn't it? The squaring is called a function, the square function, that is. So x is what you give and y is what comes out. Like same y equals x square, you take. You keep inputting the values of x. X equals 1 is input, output y is 1. The input x is 1, the output y is 1. The input x is 2, output y is 4, like that. Do you follow? Sai Ganesh.
Yes, sir.
This I'll be recording, so I'll be sending it anyway. You can listen to it once again. I'm going very slow. Now, to make it even more further interesting, I generally go for this. If at all you have a problem of what is this function, why is a function of x, many times we use it, but we don't think in a very what you call fundamental way as to what's happening. Look, this function is like a machine. Like a machine. It's only an analogy I'm bringing to make the meaning of function very clear. In this machine, you put some input. It does something and gives out the output. Output f of x is given an additional name called y. Y is f of x, we told you, no? This f of x, function of x, is called y is f of x. Okay, this f is like the machine. You keep pouring something into the machine. This machine does some function there, and it gives out an output. Okay, now what is the meaning of this? You can look at that. An example we're looking at. Square root function s equals root t we have. S equals root t. The name of the function is root function. Here, name of the function is root function. Nothing, it does a root to whatever you give. So we can write function t is root t. That's what it means. But what is happening? Say, for example, I don't know whether it is there already. If it is there, okay, I'll just give it here itself. Look at this. I told you this is something like a box I have. This is going to do a job of finding with the square root of whatever you put into this. I'll put 25 here. this is x, and this x is 25 I input. This function does root of it. How much is the output? Plus or minus 5. Do you follow? And x is
Yes, sir.
some 16, for example, into this. That will be doing the function of finding the square root and kicks
Plus or
out
minus 4.
plus or minus 4 like this. This is the meaning of a function. Square function, for example. Square root function, for example. Sine function, for example. What do you mean by sine function? Y equals sine x, you say. So x is our input, which you also call independent variable. You put a value for that. Sine 30, you say x equals 30 degrees. So what will be y? 1 by 2.
1 by 2.
X equals 45 degrees, or radian. In terms of radians also we can give pi by 4. So y is how much?
1 by root.
1 by
Root.
root. And x equals 60 degrees, for example. Y is what? Root 3
Root
by
3
2.
by 2.
X equals 90 degrees, for example. Y equals what?
1.
X equals 0, for example. Y equals 0. So who is doing the function here? Sine. Sine is the function. So it is like a machine which actually does something to the input you put and converts that and kicks it out. So this is the meaning of a function in a very, very simple way. Tell me. There are many ways of representing a function in a mathematical sense, but this should actually make things meaningful to you. Tell me, children. Any questions, Sai Ganesh?
No, sir.
And who are others, children?
No question, sir. Yeah.
Let me see who are all there. Sai Ganesh, some people are missing. I don't know. Who is that? Suhita, are you there?
Yes, sir.
Okay. All right, I'll continue, children. Now, another example. What does this function do? S is f of t equals t square minus 4. This may be displacement or distance, whatever, is a function of time. As the time changes, displacement also changes, is the meaning of it. So if I put t equals 1, the function squares it, square function this is, and subtracts 4 and returns the result as minus 3. You understand? This is a square function in time. It's a function of time when you said, but that function of time can be square function or root function or whatever it is. So t equals 1, we put 1 minus 4 minus 3. So the displacement comes out as minus 3. Okay.
Okay.
Just 1 second. Let me go to your group. So I'm just going on talking, but is it is some meaning registering in you, in your minds?
Yes, sir.
Children. Right. Now, like, yeah, what was the old thing function we took? S is t square minus 4, right? So look at that. S equals t square minus 4. Here t greater than 0 we are putting because that is time. So 0 you put the input. it is giving out -4. 1 you put, it is giving -3. 2 you put, it is giving 0. All right. So you can plot a graph of this. S equals t square minus 4 graph. You can plot and see that function in the form of a graph also. Look, function can be represented in various ways. You can write in an algebra equation like this, just leave it. Or you can show a table like this and show that. Or you can plot a graph and show that. Or you can just map. I'll show you that in the next slides. So all these ways are the way we write the functions, children. Any question? Suhita and others?
No, sir.
No, sir.
No, sir.
Okay. You actually will be doing much more about the function business in mathematics, but I want the meaning of it for us. So I want you to keep responding. If there is anything looking new and difficult, just feel free to say that right now so that I can talk anything extra about it. Now, but there's a word relation also mentioned previously. Look at this. It is simply a way to map or pair an input with output. In mathematics, you call ordered pair, all that will come. I'm deliberately not using those technical mathematical words. It's a way to map or pair an input with output. That way is a relation. Look at this. This is one relation I'm taking. 2 plus t. T equals 0. See, this is algebra way to show the relation. This is the table. T equals 0 you put, V equals 2. T equals 1 you put, V equals 3. T equals 2 you put, V is 4. T equals 3 you put, V is 5. So we are mapping time and velocity. We are pairing time and velocity like that. That also can be done like this. People put one ellipse here, another ellipse here, put 0, 1, 2, 3 here, 2, 3, 4, 5 like that, these things, and then keep mapping like that. Later, you will give names like domain, range, all that you keep giving in mathematics. I'm not using those words yet because I simply wanted you to get the feel for it. But there's one more relation shown here. Look at this. Instead of taking 2 plus 3, 2 plus or minus 3, I'm taking. So t equals 0, 2. T equals 1, tell me. 2 plus 1, 3. 2 minus 1, 2. Sorry. How much did I say? T equals 1. 2 plus 1, 3. 2 minus 1. What should I get here? T equals 0, 2. All right. T equals 1. 2 plus 1, 3 is 1. 2 minus 1?
1.
1. Similarly, t equals 2. 2 plus 2, 4. 2 minus 2, 0. So if I map it like this, what's happening, you know? For this input of 1, there are two outputs, 2 and 3. In a similar way, for this input of 2, I've got two outputs, 0 and 4. Do you follow? Hello. But
Yes,
both
sir.
these things can be called relations because it's simply a particular way to match something called input, something called output. And for a relation, it's not like that for a given input, there should be only one output. There can be many outputs, the way you see. But function is something, a special kind of relation where there is only one output for every one input. That is the difference between function and relation. Tell me, children. I'll give a little time for you here. I'll give you a little time here. A relation is generalized name. It simply tells you something is related to something, right? And in our simpler language here, a value of x is related to a value of y there through this relation, v equals 2 plus t, or v equals 2 plus or minus t. But remember, this relation will be called a function. This is not a function. This is a relation only, because one important thing for a relation to be function is that for a given input, there should be only one output. Tell me. They're all technical words, ordered pairs, what all, I mean, I don't get those names right now. I'm not at all using those words. I just want only the very, very simplified meaning of the function for our purpose without saying it in a wrong way. All right, I'll continue. Yeah, function, a relation in which there is only one output for every input. Every function is a relation, but not every relation is a function. Do you agree now?
Yes, sir.
And people say there is a vertical line test. If you show the function by a graph, I told you already, function can be shown in many ways. In algebra expression, you can, this v equals 2 plus t is shown here. This is the algebra way of showing a function. This is a graphical way of showing a function. And this is a mapping way of showing a function. And you also have a table way of showing a function. Do you follow my point? T and v, if I show 0, 2, 1, 3, 2, 4, 3, 5. So a function can be seen, visualized in our two-dimensional paper space this way, either by this ellipses and mapping from 0 to 2, 1, 2, 3, 2 to 4, 3 to 5, or just by mapping with a table, or by just only showing by a algebra relation, or by a graph. So I told you already what distinguishes between a function relation is that you have for every input, that is a value of x, which is called the independent variable, which you keep giving that value. For that, there should be only one output there. Do you follow? But in a graphical way, there's a simple way to check whether a given relation is a function or not. A vertical line, draw like this. If it cuts this graph at only 1 point, it is a function. But if it cuts the graph at 2 points, it's not a function, it is a relation. Tell me now. Do you understand this point?
Sir, what is a function in v equals to 2 plus t?
It is a function which adds to 2 and then gives out that number out of it. You put a t equals 1, for example. So whatever that machine is there, is adding 2 to it every time. So there's nothing like a name for that, right?
Yes, sir.
Okay. So, but do you understand this vertical line test? If vertical line cuts the curve at 2 points, for example, it means for a given input, there are 2 outputs. This is y, this is x, right? So for given x here, there are 2 y's, which is not a function. Do you follow my point?
Sir,
Yes, sir.
I didn't understand why the graph of the relation is like that. Why is it in a circle, sir?
Niketa, who is this? Tell me.
Sir, why is this true, sir?
Which one is true?
The law which you just told us, if we draw a line through a graph, vertical line.
This time I showed, here. First of all, did you understand x is the input, y is the output?
Yes, sir.
Now x has only one value here, but there are 2 values related to this y.
Okay.
But here there's only for one x, so there is only one y. Wherever you cut, for every x there is only one y. For this x, there is one y. So for x input, there should be only one output, not two. If it is two is there also, there's no issue. We can call it only a relation like this. Look, for 0, 2 is there. For 1, there is 3 and 1.
Okay, sir. Yeah, got it.
For 2,
Yeah.
there is 0 and 4. So there are two outputs for a given input. So this is only a relation, whereas this is a function. Tell me, this is going to be very important even in maths. People, when without trying to understand the meaning of it, try to do problems. But once this is understood, life will be meaningful. Tell me, children, others. Ramakrishna. Can I continue, children?
Yes, sir.
Actually, remember why this function thing has come in the middle, you know. I was trying to talk about this. If y is f of x, if there is a change in x, which we may term as delta x, that brings about a change in y, which you call as delta y. We are generalizing this, whereas we have already seen with examples. But look, in sciences, you can't use words indiscriminately. You should define them. You should give an accurate way of understanding it. And in sciences, of course, that will take the mathematical form. When I said y is f of x, what I mean to say is that I've got something called a function that does something to the input given and gives out an output. Y equals x square function, when I take, there's a square function basically. Whatever thing you push inside, that squares it and sends it out. Okay. So it also means that as the x values we take on our own, and y comes out with the values after the function operating over it. The square function operating over it will give you 4, 9, 25 like that. So in that connection, I just wanted to give a small introduction for the meaning of the function here, more than the logical way of talking about it. More accurate way of talking about it comes in mathematics, but this is definitely which opens our eyes to the meaning of function. Even there, finally, you will say that for every x input, you'll have only one output. You will say that. So what differentiates a relation from function is that in a relation there can be many outputs for a given input, whereas in a function there will be only one output for one input. Tell me, children. Sai Ganesh and who is that fellow? Vasist.
Yes, sir.
Vishnuvardhan. Few others, please.
Yes, sir.
So can I continue, children?
Yes, sir.
Okay. Now, this vertical line test. Can I continue?
Yes, sir.
Now, what is delta x? I'm just going for finer details of what the words we have said. Can you recollect that statement we mentioned there in the beginning? In the beginning, before we started talking about a function, we told if y is f of x, or more details, in more detailed words, if you want to say, if y is a function of x, a small but finite change. Every word is used with care. A small but finite change delta x will bring about a change delta y, and why we use the statement. What is this delta x? It's not delta into x. It is difference in x. Delta x is a final value minus an initial value. of that independent variable. Look at this. If y equals x square is taken, x and y you show in a table like this. X is 0, y is 0. X is 1, y is also 1, isn't it? 1 square. If x is 2, after squaring, it becomes 4. Now you can check it. Here, between these two, x2 minus x1 is 1 minus 0. Or later also, 2 minus 1, 3 minus 2. I've given in such a way that the delta x is same everywhere. But if I take between 4 and 0, x2 minus x1 is 4. And similarly, accordingly, y2 minus y1, 16 minus 4 for these two values, for example. So 4 minus 2 is delta x, 16 minus 4 is delta y. Do you follow my point? Delta x is, this may be small, but finite. Finite, when you said, is simply countable, measurable. Infinitesimally small means it is so small that you cannot measure it, or it is smaller than whatever you say. That's what mathematicians keep saying. How small means whatever you say, it is still smaller than that people say. That's called infinitesimally small. But here, delta x is countable. Okay. Now, graphically also I can show that. So graphically, a function may be like this. We don't know what name of the function, but simply y equals f of x, I'll say. It could be some y equals x square, something like that. Don't worry about it. So a point here, which you call a, for example, is represented by the coordinates x1, y1, or ordered pair x1, y1, whatever you say. If people write in geometry this way, a, x1, comma, y1. B here, x2, comma, y2. So on the function, when you go from a to b, you are looking at a situation where x1 is changing from, this value is changing from x1 to x2, this one, this much. As a result of which y is changing from y1 to y2. So this is y2 minus y1. Do you follow? Tell me, y is a function of x. That means you took a table of x and y and put many values and you joined those values, you got a curve like this, the graph like this. So on the graph, I want to show what is delta x and delta y. I'll show like this. A final value of x minus initial value of x. This is this one, children. And this is delta y. Do you understand this one? In algebra, I showed here what is x2 minus x1, what is y2 minus y1, I showed here. And then later we showed in the graph what is y2 minus y1, what is x2 minus x1. Tell me, children. Dhanush Chandra, are you here? So, children, can I continue? What is small but finite? I just, to make it interesting, I've given you this example. It may be small but measurable or countable. Can you tell me what is this I'm saying? Just put it in a lighter vein. This is what? Tea. This girl, a lady, is sipping it. It was 100 ml first. So in one sip, she could take 10 ml, let me say. So this is my T1. It's not time. I'm just putting it deliberately like this is my T2, this is my T1. So my T2 minus 7 is minus 10 ml. Similarly, here also minus 10 ml, minus 10 ml. Finally, what will happen? All this 100 ml gets over. So delta T plus delta T plus delta T plus delta T has become your T. Help me. So that's what I'm trying to tell you is that delta T is small. This for rhyming case sake I put. Huh? Do you follow? This is actually, I can put it in volume. Each sip is delta V actually, not delta T. Do you follow? Hello?
Yes, sir.
Now, then what is rate? I was just going on explaining each word we mentioned there. The speed or the quickness or the slowness with which a quantity changes is what you call a rate. This rate is very, very important. It's a part of our daily lives. When you go to a vegetable market, you'll ask, what is the rate of apples, he'll say. Isn't it so? He'll say per kg 20 rupees or 200 rupees, whatever it is, I don't know. Per kg they will say. They don't say some 1,000 rupees you give like that, isn't it? Every time per unit will give you accuracy to your understanding. So now for a change delta x, the change is delta y in y. So for a unit change in x, what is the change in y? For delta x, the change is delta y. For 1, how much? Delta y by delta x. Do you follow?
Yes, sir.
X is changed by delta x. I told you what is delta x already, right? So for a delta x change, the y's change was delta y. So for 1, how much? Is it not 1 into delta y by delta x?
Yes,
Huh? Tell me, children.
yes, sir.
This, then we call this as average rate of change of y and x. This delta y by delta x is called what? Average rate of change of y on x. But y average rate we'll talk now. Okay? Children, I'm waiting for your feedback.
Yes, sir.
Because I told you already, this is slightly abstract. Because we're talking everything in algebra terms and talking big words, all that. Though I'm trying to make it interesting by giving you some nice examples. I'll give more. Look at that. Sai Ganesh, just see what is this? World Cup 19. India 352 by 5. Australia 316 for 50. India won by 36 runs. Shikhar Dhawan 117 in 109 balls. Okay. Now we talk of the run rate, don't we? Hello, children.
Yes.
Yes, sir.
Actually, as physics students, you should say average run rate, not run rate. You should say it as what? Average run rate. Why? I'll tell you. This is, I want accurate this thing. If I have a calculator, tell me. 352 runs in 50 overs. So what is the average run rate?
70.
7.04, sir.
352 is there. You can make it 350. Okay, let us make it 350. Let us take a little liberty.
7.04, sir.
7
352.
or otherwise 7 point whatever. So this is 7, and here 316 by 50. How much you tell me? 6 point
6.32.
6.32, sir.
6.32.
32. Yes,
Huh?
sir.
Yes,
32.
sir. 3-2.
Right. So that's why India won. That's why Australia lost. Does it mean to say that in every over Indians were hitting 7 runs?
No, sir. On average, that's how much they had.
Right. That's why it's average. That means the runs were not being scored uniformly. It's not that for every 1 over they were making 7. That's a uniform rate. Huh? 1 over may be made in also. In 1 over, in particular over, there may not be runs at all. But on the average, they scored 7 runs per over. But on the average, Australians scored 6.32 runs per over. That's where they lost. You understand why the word average? And not only here, Shikhar Dhawan's average strike rate we can see. Okay, 107 by 109. How much is that?
1.09.
117, sorry. 117.
1.09, sir.
1.09. That means nearly 1.1 runs per ball he hit. Do you follow? So does it mean to say in every ball 1.1 runs will be made? Meaningless, isn't it? There will be 1.1 run will be there anytime? No. But on the average, the strike rate is this 1.1. So tell me, what is this average business now? That means for a particular value of x1 to x2, on the average, how much y changed? On the average, not at a particular x, but between x1 as a whole, how quickly y was changing. That's what we mean by delta y by delta x. The thing is, y need not have to change uniformly on x. That's where the word average becomes important, children. Huh? In a similar way, I can give you one more example. What is this? Can you see the screen properly? In the first ever World Hard-Boiled Egg Eating Championship, whatever, Joy Chestnut devoured the world record with 141 eggs in 8 minutes. So, per minute, his eating rate is how much? Tell me, children. Average rate of eating eggs.
$17.625.
How much?
17.625.
17.6
625.
to something. That means, oh, it is very big. That means in 1 minute he was eating 17 eggs on the average. But remember, definitely he may not have eaten in every a minute 17, right? Huh?
Yes.
In the beginning, they may be slow because he's watching others. Then he pushes more eggs into the mouth as he sees the competition with others. Do you follow?
Yes, sir.
The eating rate is not uniform. Therefore, over a wide period of time, when you mention the rate means per unit, remember, you have to use the word average, on the average, as a whole. So that's the meaning of average rate. Okay, children, I'm explaining just one statement I put in inverted commas. What is that? When or if y is a function of x, a change delta x in y in x brings out what? A change delta y in y,
Right.
and delta y by delta x is called what? Average
Average.
rate of change of y on x. Average rate of change of y on
X.
x. Average rate of change of y on x. So only that word I used, but I wanted to explain everything. You can't simply say y is function of x like that. Hello. More of the function you learn in mathematics, but for us, maybe that's not so bad right now. Children, can you continue?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Function y need not have to change on x uniformly. Therefore, the term average. Okay. Now, but I'll give you a few examples. Come on. Look. The mathematics of this I'll show you. Example. What is that example? I'll tell you. If y equals x square, find delta y by delta x. Just watch out for the steps I am going to use here. Look. What did we say? You need to bring a change delta x in x. That should result in a change delta y in y. So x should be changed to x plus delta x, children. So x plus delta x whole square I should write, because the square function. But because of which y changes by delta y. Do you agree?
Yes, sir.
Yes, sir.
Y is depending on x. So somebody is bringing a change delta x in x. So don't say x square plus delta x. It should be what? X should be changed. The function will be still square function. Try to understand. Not do you change the function? Huh? Hello.
Yes, sir.
You should not say x square plus delta x, children. Do you follow?
Yes, sir.
Now delta y will be x plus delta x whole square minus y,
Yes.
isn't it? This will be x plus delta x whole square minus y is what actually? X square. So simplify it. X square plus delta x square means actually I will put in brackets not to get confused. Plus 2x delta x minus x square. Is it okay? A plus b whole square. All right. So delta x, if you take common, 2x plus delta x. So delta y by delta x equals 2x plus delta x. One more statement, one more note I would like to make. The value of delta y by delta x depends upon the choice of the interval delta x. Very important note is this. So after so much of talk, the summarization is very, very simple. We'll come back to the summary once again. Look, I use the word, the value of delta y by delta x depends upon the choice of interval delta x. What is the meaning of that? With a simple example, we can understand it. This only you take. We took the change in x here, the overs, number of overs from 50 to 0 overs, right? But if I take 0 to 20 overs, tell me, will this rate be same?
No, sir.
No, sir.
You know very well, most likely it should be lower in 0 to 20.
Yes.
Isn't it so? T20
Yes, yes.
game, you know very well. In the last 4 hours, they hit 60 runs, for example. That is 15. But in 20 overs, the run rate may be only what? 8. If the total score is 160. Do you follow my point? In the first 15 overs, they've scored only 100 runs. But later in the last 16 overs, but in the last 4 overs, they scored 60. So this average run rate is depending upon which overs you take, isn't it? Huh? The number of overs is X, right? Number of Y is number of runs. So that's what I mean by saying that the value of delta Y by delta X depends upon what? Tell me.
Choice of interval of delta X.
Delta X. Average speed also. For example, Telangana Express starts here at Secunderabad, reaches New Delhi in 36 hours, for example. So if the distance is 1800 kilometers, for example, 1800 by 36 hours. What is this? How much is this?
50.
How much?
50, sir.
50, na?
No,
Isn't
no,
it?
sir.
1800s, 18.2s, right? So
Yes, sir.
50 kilometer per hour.
Yes, sir.
That means between Hyderabad, Secunderabad and New Delhi, it is 50. But can I say that between, say, Secunderabad and Bhopal in the middle, it is 50? We don't know, right?
Yes, sir.
That may be something else. There's average speed only, right? The average speed will depend upon the time interval you consider. Do you follow my point? And we can see here in general terms, delta Y by delta X depending on the value of this delta X. So this particular statement is very, very important. From here, I'll go to talk about the next class, the instantaneous rate. So until now, tell me whether you understood what all I spoke.
Yes, sir.
Sir, I have a doubt, sir.
Yeah, please.
Sir, in the sum, sir, like why did you take x plus delta x, sir, in the first step?
Tell me, somebody else. Why am I taking X plus delta X? Or what do you want to take,
Sir, like I'm asking why did we only take delta x, like other value, why x2 or x?
I did not get your point. This is generalization, right?
Yes, sir.
X1 is X. X2 is X plus
X1.
delta X. Delta X.
Yes,
So X2 minus X1 is delta X.
Yes, sir, got it.
First over to second over. It is 2 minus 1, 1. First over to third over. It is 2. First over to 20th over. 20. So I can't say 2 or 3 are like that. I'm putting that as a generalized
Delta X.
way of saying
Right.
delta X, the change you brought in X.
Okay.
Delta X stands for difference, right?
Yes, sir.
So I mentioned here, look at this.
Yes, sir, got it.
Okay. Anything else? In the beginning, no issue. You can ask anything, children.
Sir, did you post a SLS class in YouTube?
Moshagnya, what did you say?
Sir, did you post the SLS class in YouTube, sir?
Actually, by
recording.
mistake, that Newton's laws got posted. I'll post it today. But that and this.
Okay.
Actually, another lesson came into that old lesson. Newton's laws came in, so I did not send the link to you. Today I'll post this and as well yesterday's and send the links to you. Okay. But listen to it carefully. The whole idea of recording is that now, if you did not follow something, nothing to bother. Just listen to the same thing again. Then you'll start getting doubts. Okay, children? Yes. For the present, I'll be closing this. And tomorrow, of course, my class may not be there. Anyway, in the timetable, you'll be knowing it. Like outer series, mostly. I'm closing this, children. Okay.
Thank you, sir.
Good night.
Thank you.